And now for our last type of factoring. This is it. I know, it's a sad day, but we do need to review one more time that the first thing you always look for is a greatest common factor. The second thing you do is you look to see what kind of terms you have. If you have two terms, we look for a difference of two squares. If you have three terms, we look for just basic trinomial factoring. We have a special type of trinomial factoring called perfect square trinomials. That's what the first set of four problems here reviews. We also have four-term factoring, and we did a type yesterday called 2 and 2. And we're going to do one more type of four-term factoring today. Keep in mind that it can only be one or the other, or none. You can't have four-term factoring can be 2 and 2. It can be what we're going to call 3 and 1 or 1 and 3 today. Or it can be none. It just might have to sit there. So let's go back to review. In review, a perfect square trinomial is identifiable because the first and the last term are perfect squares, and the middle one is double the product of the square roots of both. So when I do a perfect square, we look to say, what is 16x squared, the square root of that? That would be 4x. 9y squared comes from 3y. This is a minus sign in front of the 24, and 3y times 4x times 2 is 24xy. So we're pretty sure that we can put a square up here and express that as a square. Number 2, if I look at what this is, this would come from x and from 5y. It's all pluses, and 2 times 5y times x is 10xy. So we can put a square there. Number 3, if I look here, I have a 9n squared and a 16, 3n and 4, plus 3n times 4 is 12n, times 2 is 24n, so we can put a square there. And number 4, if I split this up, I could have a 2m and a 9n. 2 times 9 is 18, times 2 is 36, put a minus and put a square, and that's it. So 3 and 1, we have one of those things that we just did. We also have another term. And furthermore, that other term is itself a perfect square. So what I like to do with 3 and 1 factoring, I first want to show you how some of you guys will try to do this. Some of you may start to group by 2 and 2, and you see that you can factor a t out here, giving you a t plus 4s. But in the next one, you really can't factor anything out, and that might confuse you. So we have to sort of erase and start from scratch and try a 3 and 1 pattern. And that's kind of important to try. In fact, I always look for the 3 and 1 pattern first, and then I look for the 2 and 2 pattern secondly. It can't be both at the same time. It's going to be one or the other or neither. 3 and 1, I'm going to take a highlighter and I'm going to look for perfect squares. We're going to look for 3 of them, because if we have 3 perfect squares, we probably have a 3 and 1. Here's a perfect square. I've got a t squared. I also have a 4s squared, and then I have a 25p squared. Those are all perfect squares. Once I've identified the 3 of them, I look to see which one has the minus in front of it. This one has the minus in front of it. And then I also look to see, look at the one that doesn't have one. Which 2 does it come from? It could never come from the 25p squared. It comes from the t squared and the 4s squared. Put parentheses around that, and we have probably identified a perfect square trinomial. This is a PST minus another square. So what I'm going to do is I'm going to keep the other square where it is, but I'm going to factor this as a perfect square trinomial. That would come down to be t. Then I have 2s, that's a plus, and I know it's a square. Check just by foiling. T squared plus 4ts plus 4s squared. That works. Then I still have the minus 25p to the second. So, we started off with a perfect square trinomial. We got down to this, but we are not done, because we have a minus sign in between two terms. This is another factoring pattern that we have done before. It is something squared minus something else squared, which we split into ginormous parentheses, with a plus and a minus. If I look at the first, I take that and make a group of t plus 2s, and I look at the second and I make that a 5p, and then t plus 2s minus 5p. Now I'm going to drop the inward parentheses and make it t plus 2s plus 5p and t plus 2s minus 5p. Okay, let's do another example. I'm going to take the highlighter. I'm going to look for perfect squares. I have a perfect square here, 16y squared. I have an x squared, and I have an 81. Okay, now we're going to look at the remaining one and figure out which two did it come from. 18x would have to come from x and from 81. Once you've got that, I'm then going to take this and I'm going to call that the perfect square. Now, where's the minus? The minus is in front of the x squared. So this is now going to be not a 3 and 1, but a 1 and 3. I'm going to keep it as a 1 minus a 3 here. What I mean by that is 1 term minus 3 terms. So I have to do one thing before we get going more. I have to say 16y squared minus, and I have to put the rest of this in parentheses. Just like if you look up, I put the other one in parentheses. I have to put this in parentheses, but I also have to factor a negative out because I have a negative like kind of in front of the first one. We want it in front of everything. X squared plus 18x plus 81. This is the most difficult step of this, is just grouping this stuff as it needs to be grouped. Next, I'm going to factor this as a trinomial, or a perfect square trinomial. I'm going to make it a binomial squared. That would have to be x plus 9, because x times 9 is 9x, times 2 is 18x, and that gives us the middle term. Okay, now we're going to factor this just like we did before as a difference of two squares. Something plus something, something minus something. 16y squared becomes 4y, and the x plus 9 squared just becomes x plus 9 in parentheses. And then we have 4 not y, and the same x plus 9 in parentheses. Next, I'm going to distribute within the parentheses and get rid of the parentheses. 4y plus x plus 9, just the inner parentheses, we're going to get rid of them. And then 4y, up, distribute a negative, minus x minus 9. Okay. Number 7. See if you can predict this now. First step, look for 3 perfect squares. 36 is a perfect square. 9x squared is a perfect square. Y squared is a perfect square. 6xy is not a perfect square. Okay, next. Look to see what's the one that doesn't have the perfect square. Where did it come from? I see an x and a y, and I see a 6. Now, 36 may be tempting, but really we need to have an x and a y in there, so it's going to come from those. Now, the 36 is positive. The 36 has to come first. The minus, I'm going to pull a negative out of the rest of this. 9x squared plus y squared minus 6xy. And then I'm going to reorder that in descending order with relation to the x's. 9x squared minus 6xy plus y squared. Now I'm going to factor that trinomial as a binomial squared. That would have to be 3x with a minus y squared. Now we're going to split it up into a difference of two squares, because that's what we have now, a difference of two squares factoring. So all of this was the perfect square trinomial step, and all of this is the difference of two squares step. This would be 6 minus parentheses 3x minus y, and 6 plus parentheses 3x minus y. Now we distribute the negative. 6 minus 3x plus y, and then drop these parentheses, 6 plus 3x minus y. Next step, or next one, look for 3 perfect squares, m squared, n squared, and uno. All of those are perfect squares. The 2m would have to come from an m, but it also comes from a 1. So why does it come from a 1? Well, it can't possibly have come from the n squared. Then we look to see, well, okay, now what's positive? What order should we shuffle these into? The one that's off by itself is the n squared, and it has a minus in front of it. So that's going to come off to the right. And then I have an m squared minus 2m plus 1. Parentheses around that, and factor that part as an m minus 1 quantity squared, and then minus an n squared. Now we're going to split it up into two binomials, so parentheses, the plus and a minus, and I have m minus 1, parentheses, plus n, and m minus 1, parentheses, minus n. So then I have m minus 1 plus n, and m minus 1 minus n. Next, if I look at this, I'm going to look for perfect squares. I have none. I have no perfect squares. I could be done, or I could check for the 2 and 2 pattern. In the first one, I could take out a 3k, giving me an h minus 2k. In the second one, I could take out a negative 4, giving me an h minus 2k. And then in between both of those, I can take out an h minus 2k, giving me a 3k minus 4. Notice how I check for the 3 and 1 first. Let's look at number 10. Okay, do I have perfect squares? I have 1 here, I have 1 there, and I have 1 there. I have 3 perfect squares. The one that's remaining, 12x, comes from the 4x squared, and the 9, it couldn't come from the y because it doesn't have a y. Furthermore, the 144y squared is positive, so that's going to go first. I'm going to write the rest in descending order. Minus 4x squared plus 12x minus y. Now I'm going to group this and pull a negative out, so I have 144y squared minus parentheses 4x squared minus 12x plus y. I can see now that that second part can become a perfect square trinomial. So I have 2x plus 3 squared. Now we can do our difference of 2 squares step, big parentheses. The first term would be 12y's minus plus, or plus minus. Let's make that bigger. And then 2x plus 3 and 2x plus 3, parentheses on both. Last step, distribute your negative, 12y minus 2x minus 3, and then 12y plus 2x plus 3.